Hello everybody and welcome back to Algebra 2. Today we're going to be talking about 5.4, dividing polynomials. Let's begin. So let's start off with a little vocabulary. Circle the factors of x cubed minus 4x squared. In order for something to be a factor of that portion right there, that polynomial, we need to now know that if we multiply whatever that factor is by something else, our end result will end up being the x cubed minus the 4x squared. So if I were to actually go through and multiply every single So let's start off with a little vocabulary. Circle the factors of x cubed minus 4x squared. In order for something to be a factor, it's basically going to have to be something that we can take out of that polynomial that's given. So in other words, it needs to have what we need to take out. So if I'm looking at it, I see an x cubed and I see a minus the 4x squared. Well, seeing the x and the x makes me know that I can take out an x of some sort. To which I'm going to reply with the lowest exponent x that I've given. So the x that I can take out is actually going to be an x squared. So I know that one of the factors will actually be that x squared. That being said, if I can take out an x squared, there's a small chance I might be able to take out an x cubed. But in this case, if I took out an x cubed, that's going to give me one more x that I need to be taken away from that 4x squared, which means I know that I can't actually take out that x cubed. Right? If I were to take out the x squared, I'm going to be left with the x minus 4 inside the set of parentheses, because I know that x squared times x will give us that x cubed, and that x squared times the negative 4 will give us that negative 4x squared. So I do know that that is in fact a factor. Now these are the two main factors that I'll talk about. So can we take out a negative 4x squared? So just out of curiosity, is it possible for us to factor out a negative 4x squared? Well, although we do have it at the very end, we cannot divide a negative 4x squared from that x cubed, and therefore I'm actually not going to consider that a true factor. Number 2, cross out the expression that is not a factor of 2x to the 5th plus 8x cubed. In order for something to not be a fact, that means that we can't take it out, period, in general. So looking at the x squared, you absolutely can take an x squared out. Why? Because the lowest exponent that is given is the x cubed. We have the 2x cubed. Well, looking at this, both of these share a 2, so we can absolutely take out that 2. And we do have the x cubed that will go into all of that, so that is also fair game. If I were to take out the x cubed altogether, I know that the 2x squared plus 8 is going to be a straight up factor right then and there. So therefore, I do know that this is in fact a factor, leaving us just with our final chance of that 8x cubed. And we can see that the 8 can't be taken away from the 2, and therefore that is why the 8x cubed is not considered a factor. So let's jump into the vocabulary builder. We have our quotient, which is a simplification of a division expression. In other words, the quotient is the solution to any dividing problem. We're also going to be talking about words such as dividend, divisor, and remainder, which, as you can see in the top right corner, have a specific meaning towards any division problem. Can we circle the dividend and underline the divisor? Well, in order for us to know the true difference between the two, the dividend is going to be the number that we're dividing from. The divisor is the number that we're dividing by. So x divided by 5 means that our dividend is going to be the x, because we're going to be dividing 5 from that x. That 3.2 divided by 16, our dividend will be the 3.2, because again, the 16 is going to be divided from 3.2. In this case, we have a 15 with a 100, but this is really going to be 100 divided by 15, so our dividend is going to be that 100, and that 2 divided by 7, that 2 represents the dividend. And the divisor is everything that it's opposite, so it's the by portion. We're dividing by that 5, we're dividing by the 16, dividing by the 15, and last but not least, dividing by that 7. Great job. Problem 1. Polynomial long division. Use polynomial long division to divide 3x squared minus 29x plus 56 by x minus 7. what are the quotient and the remainder of this problem. Remember, the quotient being the solution and the remainder being whatever we end with at the very end. So in order to figure out how they got that 3x, we can kind of look at what they decided to do for the justification. So they divided the first term of the dividend, what's inside, so that 3x squared, by the first term of the divisor, which is what's on the outside. And that answer right there, in this case it gives us a 3x, is going to be the first term of the quotient. It's the first term of the solution. Now the one thing I will say is that notice they ended up with a 3x, not a 3x squared. So they're going to put their first portion of their solution above the correct term that is given underneath, the x value. So a 3x is now above the 29x. That way we know that we've covered that basis and we can go on to the next one. But what we have to do now is multiply the first term of the quotient, or the brand new 3x that we created, by the original divisor, that x minus 7. So we're going to get 3x times x, which gives you a 3x squared. We have a 3x times a negative 7, which gives you a negative 21x. But notice it's inside a set of parentheses. Well, if you remember back to normal long division, straight up what we used to do back in the old days, you had to multiply whatever that quotient portion was by whatever the number actually is, and then more importantly, when you ended up going down to the next level, you had to subtract your answer. And once you finished subtracting your answer, you brought down what was left over. In this case, we're bringing down the 56, but we are going to keep what we have, and then we have to do it one more time. That same exact thing. The only difference is we're not going to pay attention to the leading coefficient of the dividend like we did in the beginning. Now we have our brand new leading coefficient. So if I were to go through and subtract it out, this portion right here, that x squared, if I did it right, will always cancel out. That first term is always guaranteed to be eliminated. And when we go through this, we'll end up with that negative 8x plus a 56, because again, we're bringing down that 56. We then have to figure out once more, what are we going to multiply to give you that negative 8? So again, I'm going to go off to the side. We're going to put negative 8x. We're going to divide it by our leading term of the divisor, which again is x. And we are going to get that that's going to equal a negative 8. So I'm going to put a minus 8. Again, the number of the constant is going to be above the constant. Again, multiply everything out by that negative 8. So negative 8 times x gives you a negative 8x, and then we have a negative 8 times a negative 7, which gives you a positive 56. Knowing that, we do have to change up the way we end up writing out things. So they did it for one, but they didn't do it for both. So technically this is going to be multiplied by a negative 1, which is why that became a positive 8, because originally that's a double negative right there. However, the negative with that 56 would also turn that positive into a negative. So the positive 8x, which is what they should have right here, and a minus 56 is what actually goes in this spot right there. So we have 8x minus 56. If I were to add straight down after that point, you're going to end with a remainder of 0. Which brings us to the last little bit. Can we identify each part of the problem? Well, once again, the dividend is what we're going to be dividing from. So that is the 3x squared minus 29x plus 56. Our divisor is what we're dividing by, which is going to be that x minus 7. Our quotient is our solution, which is that 3x minus 8. And the remainder is whatever we had left over, which after adding everything down, we would get a 0. And then to check our solution, we just plug everything back in, and we decide basically we're going to multiply everything out, and if it ended up being the exact same thing at the very end, then we're all good. And in this case, after multiplying x minus 7, or the divisor, by our quotient, that 3x minus 8, we did in fact get the dividend, which is that 3x squared minus 29x plus that 56, which means that we did it correctly. Great job. So let's talk about a little key concept, the division algorithm for polynomials. Right? You can divide polynomial p of x by the polynomial d of x to get the polynomial quotient q of x and the polynomial remainder of r of x. The result is p of x equals d of x times q of x plus r of x. If r of x equals 0, then p of x equals d of x times q of x, and therefore d of x and q of x are factors of p of x. You followed? To use long division, p of x and d of x should be in standard form with 0 coefficients where appropriate. The process stops when the degree of the remainder r of x is less than the degree of the divisor d of x. So all this entire paragraph is trying to say, with all these d of x and q of x and whatever it may be, is basically saying, look, if you run into a situation like we had in problem 1, where our divisor ended up being the x minus 7, and we ended up getting a quotient, which was 3x minus 8, and our remainder ended up being 0, when you get a remainder of 0, that means that both the divisor and the quotient are going to be considered factors of the polynomial or of the dividend. In this case, x minus 7 times 3x minus 8 are both factors of 3x squared minus 29x plus 56. That is all this entire thing is trying to say. It's basically saying if you end with 0, they're both factors and you can move on. So, question 7, cross out the polynomials that are not in the correct form for long division. In order for it to be in the correct form for long division, it needs to represent every single possible term that could be there. So if I start with an x cubed, my polynomial needs to go to x squared, and it needs to have an x, and it needs to have a number that is by itself. It needs to have every single one of these. Now, if x cubed is the only thing that we have, then we're going to plug in a 0 for each and every one of those. It's kind of like a 0 for a placeholder when you're talking about dividing by 1,000. Right? We're not just going to consider it 1 because we need to have those zeros to represent how truly massive 1,000 is. Same thing goes for polynomials. If you have a cubic situation where it's like an x cubed but nothing else, we still need to have that 0x squared plus 0x plus that 0 in order for us to get the true idea of what both of the factors potentially could be at the very end. And more importantly, if you do not show that, your remainder will be wrong, which means that your quotient will also be wrong. I know that this one, the very first one, is not in the correct form because we started with x cubed, we went to x, which means we jumped over x squared. Starting with x to the fourth, jumping over x cubed and x squared, give you that x value. That is not the correct way to do it. However, the x cubed to x squared to x to that constant, that is 100% a-okay. So to solidify this one more time, you always have to have the placeholder, and the exponents always must count down, and you should never jump over an exponent, and you should always end with a constant. Problem 2, checking factors. Is x to the fourth minus 1 a factor of p of x equals x to the fifth plus 5x to the fourth minus x minus 5? Write, if it is, write p of x as a product of two factors. So essentially we need to just divide everything out. The only difference is we need to make sure we write the dividend properly, meaning we have the x to the fifth, x to the fourth, but as you can see we are missing that x to the third and the x to the second power. We need to make sure we put that in when we write it out. So we have x to the fifth plus 5x to the fourth plus 0x cubed. All that's really saying is that we don't have an x cubed, but it's there, plus a 0x squared. Again, there is technically no x squared, but again, it's there, minus the x minus 5. And we're going to take this step by step. So we need to take that x to the fifth and divide it by x to the fourth, and you'll be left with just the x. So I'm going to multiply by x to start off. X times that x to the fourth minus 1 is going to give me, in this case, a x to the fifth and a minus x. The only difference is there are going to be missing pieces. So anywhere from x to the fifth, the exponent needs to still count x to the fourth, x to the third, x to the second, all the way down until you get down to that x. So we are going to have x to the fifth plus 0x to the fourth plus 0x to the third plus 0x squared minus 1. And doing that, We can then simply subtract everything down, meaning that we are going to change up all of these signs. So it gives you a negative 5x, or x to the fifth, a negative 0, a negative 0, a negative 0, but a positive x, giving you technically everything is going to be turning to 0 except for that 5x to the fourth, which is going to stay as 5x to the fourth. But we bring everything straight down, meaning that negative 11 is going to come down right there. And now we have to figure out the 5x to the fourth divided by 4 divided by x to the fourth. And you'll get that we have 5. So our second number is going to be a positive 5 that we're going to multiply by that x to the fourth minus 1, giving you a 5x to the fourth with a minus 5 at the very end. But more importantly, we're going to be separating everything else with zeros. So we have 5x to the fourth plus 0x third plus 0x squared plus 0x minus 5. And since we're subtracting, we must change all of the signs to their opposites, making it a negative 5x to the fourth, which is how it gets canceled out. The 0, 0, 0, and then we have a negative 5 plus 5, which again is 0. So the remainder for this one is in fact 0. And since we have a remainder of 0, we now know that x to the fourth minus 1 is a factor, and the other factor is going to end up being x plus 5. So how would we go about writing those as two factors of the original polynomial equation? We are simply just going to write x plus 5 times the x to the fourth minus 1, which they have right here, but they also say equal to the x to the fifth power plus 5x to the fourth minus x minus 5. Underline the correct word or words, number, or expression to complete each sentence. The remainder of the quotient, in this case, is going to be 0. And therefore, the expression x to the fourth is, in fact, a factor of p of x equals x to the fifth plus 5x to the fourth minus x minus 5. Problem 3. Using synthetic division. Use synthetic division to divide x cubed minus 57x plus 56 by x minus 7. What are the quotient and the remainder? To do synthetic division, remember that the sign of the number in the divisor is always reversed. And you also have to make sure that you remember that we always have to start with a linear binomial and the leading coefficient needs to be 1. In other words, it needs to be an x or a variable minus whatever number or plus whatever number in order for us to be able to even use synthetic division. Now, they reversed the number, so it started with a negative 7, which is why it became a positive 7, they write in the top left corner. And in the bottom right-hand corner, underneath all of the coefficients that we give, I'm also going to put a remainder reminder box. That's going to tell me that that last box that I have shown right here is going to be the remainder. All right? So they say write the coefficients of the polynomial. Well, the polynomial that they're talking about is the dividend. That x cubed minus 57x plus the 56. But it jumps over that x squared. So we have 1 for that x cubed, because that is the coefficient of the x cubed. We have a 0 for that x squared because it's a placeholder, because we still, again, need to have the x squared portion. And then we're going to be left with a negative 57 based off of the x value, and a positive 56 based off of the constant. After that, you just have to bring down that 1 and then multiply across. So 1 times 7 will give you a 7, and then you place it in that next box. So we have 0 plus 7, or add straight down, and you get a positive 7 once again. 7 times 7, or multiply across, gives you a 49, put it down. Add straight down gives you a negative 8, so negative 57 plus 49 gives you a negative 8. Multiply across, negative 8 times 7 is a negative 56. And 56 plus a negative 56, or 56 minus 56, will give us a 0. Therefore, we now have our quotient and our remainder. Our remainder is easy to find, that is 0. But we have to think about what the quotient is, because the quotient is going to be written as a polynomial. And as of right now, it's just a bunch of coefficients. So in order for us to know what the polynomial must start with, we need to pay attention to what we divided from and by. In this case, we divided from an x cubed by an x. So we would start with an x cubed divided by an x. So that means our quotient must start with an x squared, or 1 less x. So now we have an x squared plus a 7, 1 less exponent gives you an x, and then 1 less exponent from an x by itself would be that minus 8, or that minus 8 constant number. So our brand new polynomial is going to be 1x squared, or x squared, plus 7x minus 8. So that 1 goes in front of the x squared, that positive 7 is right next to the x, and that negative 8 is right there. And like I said before, the remainder is going to be 0. So once again, the most important fact, you need to only be given a linear binomial with a leading coefficient of 1 in order for you to actually be able to use synthetic division. If that is the case, synthetic division is the easiest form of long division, and it will give you the answer the fastest. The one problem that I find that students run into is trying to figure out the polynomial at the very end. It's always going to be 1 less than the highest exponent given. That's one thing. And 2, just make sure you multiply across and then add straight down. Remember, multiply across, add straight down, and it should go by pretty easy. Problem 4. Using synthetic division to solve a problem. If the polynomial x to the third power plus 6x squared plus 11x plus 6 expresses the volume of a cube in inches of a shadow box, and the width is x plus 1 in inches, what are the dimensions of the box? Well, using synthetic division, I now know that I can put a negative 1 and then rewrite all of the coefficients given. So that is a positive 1 for the x cubed, a positive 6 for the x squared, an 11 for the x, and a 6 by itself in that constant spot. Draw a little line underneath everything, and I'm going to put that remainder underneath that constant. Bring down the 1. You got 1 times negative 1 gives you a negative 1. 6 plus a negative 1 gives you a positive 5. 5 times a negative 1 gives you a negative 5. And then we add straight down once more, giving you a 6. 6 times negative 1 is a negative 6. And sure enough, we end with a remainder of 0, giving us that one of our factors is going to be x plus 1, but we now know that our very first quotient is going to be that x squared, because it's 1x squared, plus a 5x, because it's 1x, plus our 6. So x squared plus 5x plus 6. And in order for us to find the other two factors, we simply just have to factor them out. So I'm going to split the x. What will multiply to 6 but add to 5? I'm going to go with a 2, and I'm going to go with a 3. So now we have that our factors of our quotient will be x squared plus 5x plus 6, which equals x plus 2 and x plus 3. Therefore, the height of the box is going to be x plus 3 in inches. The width of the box will be x plus 1 in inches, because that's what it says. And therefore, the length of the box will be x plus 2 inches. That being said, it doesn't necessarily tell us which one's the width and which one's the height. So you could absolutely interchange the length being x plus 2 and the height being x plus 3. Technically, to get the volume, you're just multiplying anyways. And since we're multiplying, and multiplication is commutative, meaning it doesn't matter which way you multiply everything out, therefore the height and the length can change, but since they told us what the width is, the width needs to stay that. Take note. Theorem. The remainder theorem. If you divide a polynomial p sub x of degree n that is greater than or equal to 1 by x minus a, then the remainder is p sub a. Well, in other words, if you were to divide 3x squared plus x minus 5 by x minus 1, the remainder will end up being whatever it would be if we were to plug in this case, the opposite of negative 1, which is a positive 1. So if I were to do the synthetic division all the way down, the answer in my remainder would end up being whatever it would be if I were to plug in a 1. So if I plugged in the 1, that would be like me going 3 times 1 squared, plus 1 minus 5. So that's going to be 3 plus 1, which is 4, minus 5, giving you a negative 1. Now, knowing that, if I were to do synthetic division using the same exact method, you're going to get that we have a 3, a 1, and a negative 5. We're going to put our remainder right there. we got a 3 times 1 is 3. Add it straight down, we get 4. Then we have our 4 times 1 is 4. Add it straight down, again we get a negative 1, which is exactly the same answer. So, using that same idea, if again you were to divide 2x squared plus x plus 6 by x plus 1, the remainder is going to be whatever we get if we were to plug in a negative 1. And doing the exact same thing, synthetically, we would end with a remainder of whatever that solution is. If I were to go through the solution, you would end up getting a 2 minus 1 plus 6, which would end up being, in this case, a positive 7. So the remainder for this problem, if we were to plug in x plus 1, would end up being a positive 7. Problem 5. Evaluating a polynomial. What is p sub negative 4 given that p sub x... Evaluating a polynomial. What is p sub negative 4 given that if p sub x equals x to the 5th minus 3x to the 4th minus 28x to the 3rd plus 5x plus 20? Well, if p sub negative 4 is a remainder when you divide, then we're just going to be dividing by whatever the opposite of negative 4 ends up being, so it would be the x plus the 4. And if we were to use the synthetic division and go through it like that, we are going to basically just set this up like we normally would. You can almost even take the number that's inside the parentheses and just put it down here, because if we're dividing by a positive 4, the number always has to be its opposite inside the box anyway. And then it's actually better to do it using synthetic division, because a negative 4 to the 5th power ends up being a massive number that you really have to worry about going through. Instead, let's pay attention to the small numbers. So we have something like the coefficient of the x to the 5th, which is 1. We then have a negative 3, a negative 28. We're jumping over the x squared, so I'm going to put a 0. We have a 5, and then we have our 20 at the very end. Again, I'm going to put our line with that remainder reminder, and we just bring down the 1, and let's start our multiplication process. Again, multiply to the corner, we get negative 4, add straight down, negative 7. Negative 7 multiply across gives you a positive 28, add straight down gives you 0. We get another 0, 0, 0, add straight down gives you 0. 0 times negative 4 is again 0. Add straight down, we get 5, and last but not least, 5 times negative 4 is going to be a negative 20. Adding straight down will give you 0. Therefore, 1, x plus 4 is in fact a factor, but the question that we're asking for is what would happen if we were to plug in an x equals negative 4 into this entire equation? What would our solution be? And our solution is going to be our remainder, which is 0. And finally, we made it to the lesson check. Let's get going through it. So a polynomial p sub x is divided by a binomial x minus a. The remainder is 0. In conclusion, what can we come of that? And can you explain? Well, if we end up having a situation where the remainder ends up being 0, then we know that one factor of the polynomial is going to end up being x minus a. So that answer is going to be true. One root of the polynomial is going to be negative a. In other words, it's going to be the opposite of that a, but if it's that case, I'm going to say that that is going to be false because it's not a negative a. Because this says minus a, that would mean that the opposite would actually end up being a positive a. And the root, or solution, is always the opposite of the factor. And last but not least, an x-intercept of the graph of y equals p sub x is at the positive a, which means it's at its solution, which is true. So if p sub x is divided by x minus a, then p of a equals the remainder, and p of x equals x minus a times the quotient of x, or q of x. This illustrates, in this case, it's going to be the remainder theorem. Right? Because if we were to divide out by the x minus a, and we ended up finding out that the p sub a equals the remainder, that is where you get that remainder theorem. If the remainder of p sub x divided by x minus a is 0, what do we know about the factors and the roots? Well, we know that since the remainder is 0, x minus a is a factor of the polynomial, and this also means that a is a 0 or a root, or in this case, a solution. And that is it, everybody. I hope everyone has a wonderful day. Stay out of trouble. Don't do anything stupid. And I'll be seeing you guys in the next one.